Hello, everyone. We're not going to start till 1. Just hang tight, grab some coffee, grab some water, and we'll start at promptly 1 o'clock.
Everyone, welcome to our session at 1 p.m. of our Digital Innovation Summit. In this session, we are honored to have Vaibhav Puranik with us. And so he is the Senior Vice President of Engineering at GumGum, which is a company that leverages data science and artificial intelligence for advertising and brand exposures. And so Vaibhav head up the entire engineering department at GumGum, including their AI teams for the last 5 years. And he has been focusing on building big data and AI teams at GumGum. He has a master's degree in computer science and 20 years of software development experience. And GumGum has just recently raised a $75 million venture fund from, I believe, is Morgan Stanley. And so congratulations that I'm going to turn the session to Vaibhav. And what we're going to do is that the presentation will be about 45 minutes. And then at the end, the last 15 minutes, we're going to open up the forum and for everyone to ask questions and participate in the Q&A. All right, welcome, Vaibhav. Take it over.
Thank you, Bruce. Can you guys hear me? Bruce, can you hear me?
Yes.
Okay, perfect.
Yes.
Good afternoon, everybody. My name is Vaibhav Puranik, and where I am right now in Los Angeles, it's morning. So those who have joined from this part of the world, good morning as well. So I'm going to talk about data science and AI in advertising field. And before I begin, I want to just give you a brief background of myself and my company so that you have the context for the presentation. So I have a master's degree in computer science. It's about 20 years old now. But since then, I've been working in software. Pretty much 15 years of experiences in big data, AI, and backend. And for last 5 or 6 years, I have been working as a head of engineering at GumGum and heading various teams, heading the entire team of GumGum. Now, one clarification I want to do is we raised $75 million recently from Goldman Sachs, not Morgan Stanley. Just want to make sure the record is straight. I think it'll be interesting to know what GumGum does so that you can understand how the AI gets applied to GumGum technology, to GumGum ads. What GumGum does is it has come up with very creative and unique formats that are, for example, what you're seeing on the screen right now is called in-image advertising. And what it does is it sort of uses an image to show an ad. At the bottom of the ad, you show, at the bottom of an image, you show an ad. And similarly, the one on the right side is the in-screen ad, which means we are showing an ad at the bottom of the screen. And even if you scroll on the screen, the ad stays there. And if you want to get rid of it, you can simply click on the cross and you can get rid of that ad. And then this is a new format that we've launched called in-video ad. And in this particular format, we have a ad shown on the lower right corner of the screen. And while the video is on, the ad shows up. So video does not get interrupted. And this is very important because we think that interrupting video is a very bad user experience. You're watching something and suddenly the video stops and you get about a 2-minute break for ads. And that's just very annoying for users. And that's why we've come up with this format where the ad will just pop up on the corner and then it'll be there for a few seconds and go away. Now, before I begin, one important thing that we do is also, we believe in not using personal information of people for advertising. And that is why when we started GumGum, we set out to do more of contextual targeting, which is a kind of targeting that does not involve using people's personal information. We want to keep the internet free. We want to keep the ads running on the internet because they actually help internet remain free. But at the same time, we don't want to use people's personal information for this cause. And we want to use AI and artificial intelligence to sort of help us in this endeavor. And later on, I'm going to explain how we actually do that. And I'm going to take one particular use case and go a little bit in depth to explain you how we achieve this. To begin with, there are many ways AI or machine learning gets used in advertising industry. It's impossible to cover all of those use cases here, but what I want to begin with is some 3 or 4 important sort of use cases that are more prevalent in the industry right now, where AI gets heavily used. So one of the most important things for which almost every single ad tech company uses AI is Kpi Maximization. And what Kpi Maximization means, essentially, KPI stands for Key Performance Indicator. And in advertising industry, there will be various KPIs that advertisers are tracking. For example, click-through rate is one of the KPI that they track. Another KPI is viewability. Click-through rate means how many people are actually clicking on the ads. If more people are clicking on the ads, then that's a good thing. That means people like ad, or people like what's behind the ad, and they want to get there, they want to engage with the ad, right? So another thing is viewability. Viewability means, is this ad been shown above the fold or below the fold? If the ad is shown somewhere below the fold where it's not visible, then it's useless, right? Whichever advertiser is spending money on that digital ad, it's useless. That money gets wasted. And that's why we want to make sure that we are showing ads only where the viewability is maximum, right? Where the ad is at the top or in the above the fold part of the screen. So that's almost every single company probably uses some sort of AI or machine learning in order to make sure that they are serving ads on the optimally on the websites, on web pages, where they can get the maximum click-through rate and maximum viewability. Another thing where AI gets used heavily is programmatic bidding. And so a lot of time when you go to a website, let's say to a CNN.com, right? You go to a website, a web page, the homepage of CNN.com, and then a few ads will appear. There'll be a banner at the top, there'll be an ad on the side, right? But a lot of you might not be aware of what's going on behind the scenes. And what's actually happening is the CNN.com page loads in your browser, and then that particular page sends out requests to 10 or 15 companies like GumGum. And they basically tell their servers that, hey, we have a space to show an ad here. Can you please send me your bid? And then all of these companies, their servers send a bid. So for example, a company like GumGum might say, okay, I'm willing to pay $10 for 1,000 ads showing in this particular space, right? Another particular company might say, well, I'm only willing to pay $8. And another company might say that, well, I'm willing to pay only $7. And another company might say, well, I'm not interested in showing ad here, right? Now, all of these bids are coming to CNN.com's webpage, and CNN.com is going to now decide which one of them to choose. So and of course, in most cases, they're going to choose the one that is the maximum, paying maximum amount, right? So then the GumGum's bid gets chosen, and now GumGum can display their ad in that particular space on CNN.com. Now, literally, all of this is happening in like very fast, like approximately about 300 milliseconds. So fraction of a second, right? And then the ads get displayed. So all of this is highly automated and happening very fast. And so these servers need to make decision making. They need to make decisions on how much to bid in this situation. How much is this web page view is important for that particular advertiser or that particular company, right? And that decision making is where AI gets heavily used, because there are so many factors on which this decision is dependent. It's almost humanly impossible to make that kind of decision and that quickly, right? So that's where you will see. So that kind of advertising, is programmatic advertising. And this is the most prevalent form of advertising these days, where every single, essentially, whenever you see an advertising on any web page, most probably what's happening behind the scene is programmatic bidding, also known as real-time bidding. And then the AI or machine learning algorithms are deciding what to bid and ultimately displaying their ads. So in the same programmatic bidding space, what happens is a company like GumGum also works with their partners. And we have many, many partners. About every single ad request that we get, we send it out to like 10 or 20 different partners within that 300 millisecond time, right? And those partners are well-known people, well-known companies like Google, Xandr, The Trade Desk, MediaMath. These are really, really reputed, well-known companies, right? And so if we are sending every single request that's coming to you to all 20 of those, right? Then just think about how many requests these companies must be getting every single minute or every single second. Just imagine how many people are online at any given point of time, and how many people are browsing web, and how many ad opportunities exist everywhere on the internet, right? And it's just billions and billions of impressions. So a company like Google or the Trade Desk get billions and billions of impressions every single second. And what they want companies to do, like CNN or even like us, is to not send them every single ad opportunity, but instead send them an ad opportunity where they're likely to buy, or they're likely to show their ad on, right? They don't want to, if they're consistently rejecting a particular website, indicating to us that they're not interested in showing ad on that particular web page or website, then they want us to be smart about it and not send that particular website request to them at all, thereby reducing the traffic on the internet, right? And traffic to their servers. And that particular phenomenon of reduction of these traffic is known as traffic shaping. And again, the parameters that go in as an input to this particular traffic shaping keeps changing all the time. And as a result, again, you have to take a decision very fast and decide whether this particular impression or ad opportunity needs to be sent to, out of the 20, how many companies should I send it to? Or how many companies are likely to buy this particular ad space, right? And that kind of prediction can be done by using AI. So that's another area where a lot of companies are using machine learning or advertising. We use machine learning for this purpose as well, to sort of reduce our servers cost and to be optimal about where we are sending our ad opportunities or requests to. Now, the most contentious area where the AI or machine learning gets used in advertising is known as targeting. And targeting means that they're trying to show an ad to you, thinking that you are most likely to respond to that ad. So let's take an example of a company like Toyota, right? So Toyota is a premier automaker, and they have their market research wing, and they have their companies, partner companies, agencies, and they do a lot of research every year, and they try to figure out, let's talk about Toyota Camry, right? They try to find out what is the segment or demographic where Toyota Camry is the most popular. So if my new Toyota Camry model is coming out, that is the demographic I need to make sure is aware of this new model, right? And let's say they figure out by their research that is the Asian people between 25 to 40 are more likely to buy Toyota Camry. Then they'll go to their agency will go to these companies like GumGum, and they'll say, I want to buy traffic from people who are Asian and between 25 to 40. And I want to show my ad to this particular demographic segment. Now, that's known as demographic segment targeting, right? Or sometimes it's also called as behavioral targeting. And I'll talk about behavioral targeting later as well. But so that kind of targeting is going on. And now, how do you know whether this particular person is Asian between 25 to 40 or not, right? And that's where the behavioral targeting comes in way. So of course, there are companies where they actually know who you are, right? For example, Google and Facebook, right? Those are the companies where they exactly know who you are. If you're Facebook, then you yourself have told that company that this is what I am, and this is what I like, this is what I don't like, this is what my age is, right? You've made everything clear to Facebook. So it's very easy for Facebook to, do this kind of targeting, right? Or even Google to a large extent, right? When you make an account for Google, right? You give them your birth date, right? So they know exactly how old you are, and they have so much of your email content and your browsing content. They can figure out, right, what's demographic segment you are, right? But all the rest of the companies on the internet, right? This kind of tracking is done using behavioral targeting, or it's simply done using third-party cookies. So there are like third-party cookies. There are companies that sort of using the third-party cookies track what websites you're visiting. And based on that, they try to make a user profile of you, right? So just to give an example, let's say a person goes to a Sephora website, then a person goes to a Disney store, and then a person goes to a women's magazine. Now they're going to say that, oh, this particular person is most likely a woman and most likely a mom too. So maybe somewhere between 25 to 40. Okay. Again, this is a very, very simplistic explanation of what that is. It's much more evolved, and there's a lot of AI and machine learning gets used to sort of figure out user profile. One more very important thing to note here is that they don't know who you are in this case, okay? So they just identify people by some random weird numbers like XYZ123, right? Because they don't know who you are. And they just know that this XYZ123 visits this kind of websites. And because of that, this person is most likely to be a mom between 25 and 40, right? None of this is perfect. A lot of AI and machine learning gets used to it. Also, it gets muddled because, if your kids are using the same browser, same device, then it's not very clear that who exactly is visiting that website. So all of that can get muddled also. Of course, the AI algorithms have now become smarter to rule out those kind of things. But that's another behavioral target is another place where AI gets very, very heavily used. Now, a few minutes ago, I told you that we don't like to use people's personal information, right? And that's where we come in. So where we use our AI is a different kind of AI. And that is, we use something known as contextual targeting. So what that means is, instead of depending on this cookie data and figuring out who you are, we try to instead figure out what is the content of the web page that you're visiting. What are the pages, what are the text on the page, what are the images on the page, and what are the videos on the page. Based on all of those three, we create a context of the page, and we use that context to target an ad. So our ad is based on what's on the web page. Now, what's on the web page is public anyways right now, correct? That's why you're visiting that web page, correct? So we're not trying to get anybody's personal information. What we are trying to do is we are simply trying to see what kind of content you're visiting at this moment. And we just try to match. So for example, if there's a sports website, maybe we'll show a Gatorade ad, right? Which is sort of more relevant to that page, right? And but in order to do that, we must understand that this is a sports website. Okay, we must understand what is the content of this page. And we do all of that using automated algorithms. And that's where our AIs come in. And one of the interesting things that's happening in the industry as people have become more and more privacy aware, And what that means is a lot of people, a lot of browsers are starting to restrict this third-party cookie activities. In fact, Safari already has banned them. Firefox has already banned them. And Chrome has set out a date in 2022, the first quarter of 2022 is when they're going to ban third-party cookies as well. And that means this behavioral targeting is going to suffer in a big way, in the future. And what's happening is, so people are sort of, all these companies are waking up now and say, well, maybe behavioral targeting is not the best way to do it because we can't even do it now, right? So suddenly companies like us who have been always doing contextual targeting from the beginning have become hot commodity in the market. And that's why you can see people like, companies like Goldman Sachs coming in and like investing significant amount of money in us because they understand the future. They understand where the industry is headed, right? And they understand the importance of non-intrusive targeting for advertising. So another thing where we use, again, I want to make sure that this is not to offend anyone, these images that you see. These images are example of what kind of stuff we do. So one of the important thing is brand safety. And so what we do is we try to figure out bad content on internet. And what does a bad content mean, right? I mean, sexuality is one of the example of bad content, or drugs and alcohol, another example of bad content, guns, violence, accidents, hate logos like swastika or KKK logos. Those are bad things. And most brands do not want to show their ads next to these things. Okay. So that's why it becomes very important for technology providers like us to detect that content and say that, all right, here, we're not going to show an ad. I'm not going to bid on this impression. This is not good for us. This is not good for our partners, our advertisers. This is not good for them. Okay. So so this is called known as anti-targeting. So what I showed you earlier was targeting, where to match an ad. Whereas what I'm showing you right now is anti-targeting. I'm not going to show an ad here because this web page contains something bad on it. So brand safety is a very, very important area where we play in. And we have very interesting algorithms that are running in the background to detect all sorts of things, right? And these are some of the examples of what the things we detect to not show our advertisers ad. So, so I'm actually going to take this use case of brand safety and explain to you a little bit more in detail. How does the AI behind the scene works so that you get an idea of how AI sort of helps in advertising industry in reality, and what are some of the technologies involved in that. So we have a API called as GumGum Verity, and this particular software essentially leverages two of the main important technologies: computer vision and natural language processing. And computer vision gets used for images and video, and natural language processing gets used for the text on the website or web page. And both of them combined is used for essentially two purposes. One is contextual targeting. That means getting a context of a particular web page, and brand safety, meaning trying to find out what are the bad things on this particular web page. So we created this API for other ad tech providers as well, because we were always doing this. We've been doing this AI for about 10 years. So we are experts in this field. And now that contextual targeting has become more important because the third-party cookies are going away, suddenly there's a demand for this kind of technology from all sorts of companies. And those companies are coming to us and seeking that kind of service from us. And that's why we ended up creating an API. It's more like an Amazon, right? When Amazon realized that, oh, cloud is what they're best at. So they said they to productize cloud and essentially start selling that service to other people. So that's exactly what we started doing. We realized that we're good at this. So we productized this service. And now we are starting to sell this service to the rest of the world. So now let's take an example of a particular brand safety context. I want to give you a little bit of idea about how natural language processing sort of works to find out bad text on a web page, right? Now, it's not as simple as it looks, right? Because a lot of companies purely and solely depend on keywords for this. But if you're depending on the keywords, it could be misleading, right? Let's take an example of this. The shooting for TV series Outlander took place in Scotland. And an officer and 2 suspects were injured during a shooting in South LA. Now, the word shooting appears in both of those sentences, but you know intuitively that the first sentence is benign because the context is different. And the second sentence is not as much benign. It's actually talking about some sort of violence, correct? So when humans are reading this, it's extremely easy for humans to understand the context. Our brain just does it intuitively because of a lot of learning that has happened from the childhood, since childhood, right? And can understand that the first sentence is okay, second sentence is not okay, or maybe that there's something more to it to the second sentence, right? So when a text on a web page gets presented to the automated algorithm or an AI algorithm, it has to solve really 2 problems, not 1 problem. So problem number 1, it needs to understand the context of the system. And problem number 2 is that it needs to understand whether this is good or bad, or this is safe, brand safe, or brand unsafe, correct? If you don't understand the context well, then you're going to make a mistake in detecting whether this is safe or unsafe. That's why understanding context is very, very, very important. And that's why what we do is we first train a model that learns about the language itself. And then we use a technology called transfer learning, where this understanding of this language gets transferred to a next model. And now next model is solely working on the task of determining whether the content is bad or not. And this kind of technique is known as transfer learning. So in transfer learning, you have 2 essentially tasks and 2 different models, but the ultimate goal for that particular model is to do one thing, which is to figure out whether brand safe or not. A particular block of text has anything brand unsafe in it or not, right? But again, in order to achieve that, you must go through a step of first understanding the language really well, understand the context of that particular paragraph really well, to understand that this is actually talking about shooting of a film or a movie or a TV series, and this is not talking about something violent, which is the shooting of a different kind, right? A gun violence, right? So that's the language model actually takes care of the first task of understanding. And there are a lot of open source frameworks like nowadays too. So you can actually get this language model pretty easily. And we use ULM Fit and Fast.ai and PyTorch. We use deep learning essentially. So what deep learning is essentially neural networks, right? And what neural networks does is they kind of try to mimic how your brain sort of learns things, right? So in your brain has millions and billions of neurons, right? And this is again very simplistic explanation. But what happens is when you're a kid and you tell your child that, hey baby, this is a bus and this is a car, right? What happens is a certain kinds of neurons light up, just to say, when it's bus, and so there are different kinds of neurons light up when it's a car, right? And then your brain remembers that pattern, and that's how you're going to know that that's how your brain remembers that this particular shape is a car and this particular shape is actually a bus. Even though their purpose is the same, it's essentially a vehicle, right? So this neural network, right? So what the software tries to do in deep learning is to sort of mimic that kind of behavior. And there are like neurons, or and then those neurons sort of are light up to say, or given positive values or negative values based on something is good or bad, or something is true or not, right? And there are various frameworks where are various neural network architectures, right, which essentially help you do that. And essentially what deep learning is on the math level is metrics operation, right? So these are n-dimensional matrices, and you have to basically do multiplication, division of those matrices, right? And PyTorch is a framework that allows you to do it very easily. And then ULMFit and FastAI sort of allow you to build an architecture on top of that, of a neural network or patterns of those neurons, right? That allow you to build an algorithm or train an algorithm sort of to understand that, okay, this text is bad and this text is good, right? So those are some of the inner workings of how in natural language processing in deep learning sort of works, right? And those are the classes that we focus on. When I say classes, means categories of badness, right? Violence is one, illegal is another, drugs, sexual, obscene, hate, disaster, malware, illness, right? Those, so we categorize all of our pages into one of these things. Or of course, the 10th one is that it's safe and none of these exist in them, right? So I mean, large portion of a network is actually safe, right? But you never know, like it could be a perfectly safe looking website, and there could be one page somewhere hidden in millions of pages where there is something bad. And of course, news websites, right? I mean, they're benign, but there could be, a disaster news about something, or, something bad, accident has been shown, and then you don't want to show an ad next to it. So the intention of those people is not necessarily bad, but you still have to detect it and make sure that your advertisers' ads are not shown there, right? And then for computer vision is considered, right? Computer vision, we do it slightly differently. We use deep learning again, but instead of trying to figure out those 9 classes, right? What we have done is we have sort of figured out our own 80 classes, 80 different kinds of images that are bad. So the first couple of them you see in the top left corner are guns. Then on the side are the swords and knives, and on the bottom is blood and gore, right? So we have defined 80 different classes like that. And then what we do is we group those classes into violence. So in this case, what you're seeing is we group all these 3 classes, blood and gore, swords and knife, and guns. We map those 3 classes to a category called violence, right? And so we essentially have a mapping of our 9 top level categories to those 80 different classes. And we use same deep learning technology to train our models on like thousands and thousands of images for each category or each class, right? And then so that the computer can learn, the servers can learn that this particular image actually has a gun in it. And this is how it works the best when it's computer vision, at least in our experience, right? If you just try to tell them, okay, detect anything related to violence, it's kind of too vague for a computer to understand that, because the variety of violence could be completely, different, or even hate logos, right? Yeah, those logos have to be trained individually, because a KKK logo might be a completely different from some other swastika, right? And those two both are bad, right? So we need to individually feed hundreds of different variations of these logos, because sometimes that logo can appear in a particular format, right? They could be tilted, they could be in a different, they could be somewhere on a mug where they're on a round shape, right? Or a cylindrical surface, right? So we need to train all of that. We literally thousands of different images that have all sorts of variations of these logos are fed to the computer, and then the algorithms learn that, oh, this has a swastika in it, or this has any kind of bad thing in it. So that's how we do for images. Again, we use PyTorch, which is matrix manipulation library, sort of. And then we used to use squeeze excitation networks before, but now we have moved to efficient net. And what happens is in deep learning, right? The state of the art, or what is the best sort of neural network architecture to achieve this kind of classification keeps changing over the years. So there's a lot of research going on, and a lot of companies actually like go and find out newer and better ways of doing things, and then they publish their papers, right, out in the research community. And our scientists are continuously looking at these things, and what they do is they benchmark their new algorithms on ImageNet database. This is like an open source database of millions of images, right? And then they say that, oh, this particular algorithm really is the best for in this class of classifications. So our people can then go and then use that open source framework and then tweak that for, or actually not tweak, but then expand that architecture to have a very specific use case of ours. So we still have to do a lot of work on our end because this is like a generic building block that is offered in the open source community. But then on top of that, we have to actually build the building or actually like then train that network to understand hate logos or understand like the text, which is bad or good, right? So our use case is very, very specific. So we have to still do a lot of work after getting these kind of neural network architectures, right? Now, video is an interesting use case, right? We sort of began experimenting with video with just because what is a video, right? In its basic, simplest term, video is nothing but a series of images, correct? It's just that those images are shown to you very, very fast in front of you, correct? Like 24, 30 frames per second is what you see in video in, correct? And so really all you have is 24 or 30 images, right? That are just shown to you within a second, right? So we started with sort of like looking at those images and then sampling those images to detect objects in images and like make it fast. But of course, then there is like much more research has gone in, and there are much better sort of algorithms that are available now, neural network architectures to be specific, available now that we use. For example, X3D is the newer one that has come from Facebook, out of Facebook AI research. And that gets used for like video detections, different kinds of video detections. So we use that nowadays to detect objects and various things in videos, right? And then what we do is, so we do something known as late fusion, right? So you have a page with images and text, and NLP did its magic on the text, and our computer vision algorithms did its magic in images. So now what you need to do is you need to combine those two and decide whether this page is safe or unsafe. And that kind of fusion is known as late fusion. And in what we just simply do is we do something known as OR logic, right? Which is a Boolean logic, where if essentially if NLP says this is bad, or CV, computer vision says this is bad, any one of them this is bad, then we're going to term that page as bad because there is something that's bad there, right? On that page, it means. So we simply use OR logic. To be fair, we use some complicated algorithms for that as well. There's a scope to use AI there as well. And not only that, what's interesting thing that's happening is there is another alternative that's coming in, which is called early fusion, and in which you're essentially trying to train one model based on text and images together. But again, that particular field is very nascent yet. And, we haven't, even though we are experimenting with it, we haven't had a great success in it. So right now, our algorithms continue to use late fusion in the wild, in the production, essentially, right? One interesting concept that I want to also explain is that there's a concept of precision and recall in the AI world. And what it means is, a precision means how accurately you are detecting something, right? And a recall means, are you leaving, how much you are leaving, right? And you need to have a balance of both of them, and especially in brand safety, right? You want to maximize your recall. And what that means is you want to make sure that, so when you're training these AI models, right, you have to make several decisions yourself. And one of the decisions that you make is this AI, should this AI model, if it makes a mistake, should it err on the caution side or should it err on the other side, right? Should it mistakenly term a good image, which has nothing bad in it, as bad, or should it say a bad image should it make a mistake on the side of terming a bad image as good? Now, you never want to have a case where a bad image is termed as good, right? Rather, what you would do is you would err on the side of caution and say that even if few good images get classified as bad, that's okay, but never ever show your ad on a bad image. Correct? That's you cannot afford. Even if some good opportunities go away, that's fine, but you don't want to show an ad, your ad on bad image, right? So when that decision is taken, what that means is we have maximized our recall, and essentially we have chosen the best possible what we do is we decide a recall and then we try to find our best possible precision for it, right? And that's how, and keep in mind that precision recall may not keep increasing together all the time. So there's a point at which they don't go hand in hand, and then you try to increase precision further, recall drops, or if you try to increase recall further, the precision drops, right? So that's why at some point you have to make a choice. What is more important to you? What side of the, if your AI model fails in certain cases, how do you want it to fail? So those are some interesting decisions that our scientists take in order to figure out, in order to train their models. Yeah. And a big part of AI is to do a data collection. And as you told you, right, we have to go through thousands and in some cases millions of images and text and feed them to computer and these algorithms, neural networks, to figure out this is an ongoing job for us. Like we have like a team of annotators that are working for us continuously, right? And while they're doing it, they're doing something known as labeling. And that means they're looking at these pages and they're saying, oh, this page has a violence thing. This page has a bad thing. This page has a illegal stuff in it. This page has a this image has something bad in it. So this image has a hate logo in it. And then what kind of hate logo is there? So they're continuously looking at images that are, and then they're giving us this data, which then gets used for training these algorithms, right? And we have to continuously keep doing that because the nature of the web is evolving. New things keep coming up. New different kinds of threats emerge on our internet, right? And so we have to be constantly on our toes to continuously do that. We have to continuously keep benchmarking our systems to understand that has our system fallen in its benchmarks, right? Is our precision reduced or recall reduced, right? And so we have to continue. So we employ companies to do this. We have our own annotators working in different countries. We have a full-time in-house people whose job is to make sure they supply our scientists with this kind of data. Like it's a big operation. It's a very, very big effort in this kind of field. Yeah, I just have I have a 1 minute left before we start Q&A. So some of the AI capabilities that we have in natural language processing, best-in-class threat detection, some categorization of websites. We do sentiment analysis. We do multiple languages, by the way. We do machine translation. We content classification, named entity recognition. That means Apple, is the word Apple referring to Apple the company or Apple the fruit? We should be able to recognize that. So that's named entity recognition. Or rather, right, is Los Angeles. There is something called Los Angeles and it's a city, right? So it should be able to understand that. So those are named entity recognition. Computer vision, we can do threat detection, scene classifier, object detector, hate, logo detector, duplicate detector. We have a lot of capabilities. And we have a tech block, which is excellent. So there are a lot of like articles related to the technologies, deep learning that we use. You can see there's a machine learning engineering, there's NLP, There's computer vision, right? Categories there. I mean, the latest blog that you see on a web blog is about actually machine learning, improving inference speeds of transfer models, right? So there's a lot on our tech blog. So go to techblog.gumgum.com and you can learn way more about our technology. Some of it is really deeply technical, so please bear with us. But yeah, I mean that's pretty much it. That's what we do at GumGum, and that's how AI gets used in advertising industry.
Well, thank you very much, Vaibhav, and for this excellent presentation and excellent tutorial on computer vision, natural language processing. So we are going to open up the forum for Q&A. Our colleague Crystal will be helping us with that.
Sure.
Hello, thank you for an awesome presentation. So a couple questions have come in through the Q&A. The first one that we have is, do you use transfer learning for both image and text tags?
Right now, we are using heavily in text tag only. We're not using an image tag.
Okay, awesome. Is your computer vision used in face recognition, like what Facebook users see, or what are the challenges in using computer vision for face recognition?
I don't think face recognition is, it depends on what you're saying, but face recognition is not a big deal these days. I mean, really, your phone can do it in like few seconds, like few milliseconds, right? So the only place where we do face recognition is we have when we try to detect sexuality part of it, we have to also understand the body positions and that kind of stuff. And we try to use face as one of the indicators there. But other than that, we don't actually do any face recognition at GumGum. There used to be a celebrity detector at some point of time, but we don't even use it now because we couldn't find a good use of that. But other than that, we don't do face recognition that much. So I won't be able to tell you like what challenges there are, but I don't think face recognition is a big deal at all these days. Of course, like if you want to know who the person is, then that's difficult, but just detecting a face on a body is really easy these days.
Great, thank you. Next question. Is there a symbol or abbreviation on an ad that internet users / browsers can look at to confirm an ad is secure?
That's a very interesting question. So when you say ad is secure, I think you probably mean that I don't understand that part, because I think most ads are right now delivered through HTTPS. So they are secure, but if you mean safety, then I think if the content that you're seeing the ad in, if you mean, okay, I think I understand what you're saying, because if the ad itself might contain some sort of malware or something bad, where you click on the ad, it's going to go to something, like do something bad to you, right? There is no one standard or one abbreviation or one icon that you can see on the ad to think that it's secure. But believe me, all big companies that I mentioned earlier, they all, including us, like we use machine learning in that space. That's one area that I missed out, which is fraud detection, right? So we actually employ another company's technology for this. And there are very, very famous companies, like there's a Double Verify. There's many companies like whose sole job is to do fraud detection in advertising. And they are scanning the images or the advertising creative itself to figure out that there is nothing bad in the advertising creative. But there is no way for you to know that it has gone through I would say the 99%, 95% of the cases, the ad has gone through those algorithms. All GumGum ads have gone through that algorithm. So you can assume that it's there. Of course, there are bad plays on the internet, and they're everywhere. But I don't know whether you can identify that having some sort of icon or abbreviation.
Thank you for that. Next question is, what are the key players in this area alongside GumGum?
There's like hundreds of companies, so in this particular space, if it is AI, it depends. So in contextual targeting, right? So in ad tech in general, there are hundreds of players, but for contextual targeting, there are very, very few players. And we are the industry's leading player. We were doing contextual targeting for past 10 years, and people had written off contextual targeting, and they said that, no, we want to do behavioral targeting, and we want to do this intrusive targeting, and that's much better. And now what happened is, now that browsers are forcing people to not do those things, that's when those companies are popping up. So there are very few companies who will directly compete with us in contextual AI. And there are almost none who are using computer vision to detect as well. Many companies use keyword-based detection, right? They purely do, like, they don't even use AI. Like, they do very crude kind of detection. Not even natural language processing, I would call it. Just like, they just bulk collect bunch of keywords and say, if these keywords appear, then it's a bad page, right? And so, I mean, Oracle is in this space as well. They bought a company called Grapeshot. But again, I don't think they are as sophisticated as we are. And there is another company called Integrated Ad Science, which is, again, we don't think they're even closer to us, right? In terms of AI that's matching. There are a few companies in this space. In general, ad tech space, there are hundreds of companies.
Awesome. The next question is, how secure is using biometric recognition? Can hackers and attackers steal biometric information after scanning fingerprint or any other recognition?
I don't have experience in that field, because that field is very specialized, but I'll attempt to answer that question. Look, to be frank, everything on internet is going to get hacked at one point or other point, right? But I think there are ways you can encrypt data, right? So that even if that information falls in hackers, right, they can make sense out of it. Right? And I think that is the best way to go forward. And that has been already done. And there are a lot of regulations as well in place, right, for encrypting that information. And plus, keep in mind that a lot of other kinds of techniques that get used in security world, which make it much more secure. For example, these encryption that we use, right, are sort of one-way encryptions. So you can't unencrypt it. Instead, what happens is, when you provide some sort of, let's say, take an example of password, right? The most common way the password gets encrypted is one-way encryption. So they're going to store the password in encrypted format, but even the company that encrypted it cannot unencrypt it and see what that password is. Okay, but when you as a user enter a password, right? What happens is they encrypt that again using the same algorithm, and then they see if the newest encrypted version matches with the older encrypted stored version or not. And if they match, then they say you are the same person, and they let you in, correct? So even if that encrypted password falls in somebody's hand, there's very little they can do with it, right? They cannot unencrypt it, right? So I think those kind of techniques get used in security world to minimize the impact of information getting hacked. So more information we encrypt, better it is. And I think a lot of companies are not encrypting like the identifiers, like the email addresses, or they're only encrypting the passwords. And so I think they need to start doing that kind of stuff too. I'm pretty sure biometric information is encrypted. I don't have experience again in that field, so I can't say for sure, but it's probably encrypted. And so it's not dangerous. I mean, it's not as bad as,
Well, thank you for answering that. Our next question is, are we relying on computer vision to get us to 100% self-driving cars? And what are some of those challenges in improving our sensor accuracy?
Yeah, again, I don't have an experience in that field, but I have experience in computer vision, so I can say that. In computer vision in general, right, you can essentially cover 80% cases very easily, right? The problem lies in the 20% of those cases, or the edge cases, right? In the imperfect world. And there are just so many of those cases, right, in self-driving, that's what is sort of hampering the fully self-driving from going into production or becoming available for the general public, right? And you can actually see that, right? I mean, a simple, I mean, I just bought a car recently, and it's not even a high-end car, and it can do a lot of stuff very effectively. It doesn't have self-driving, but it can brake if there's an object in front of it. It can even automatically increase speed and decrease speed based on the vehicle that's in front of it, right? On a freeway, it can do that. But then a lot of time it just tells me that, sorry, the conditions are not ideal, so I'm not going to I'm not going to engage my cruise control, automated cruise control, right? So that happens often. So right now, those things work only in ideal conditions. And I'm not sure if this has to do with sensor accuracy. I think it has to do with the evolution of AI and really addressing those small things and what is the cost involved in addressing each and every small thing, and whether we can even find all of those small things. I think the way to look at this is, if the accuracy of these models go above human accuracy, right? Because humans make mistakes, right? Human makes mistake in driving. As long as these algorithms are faring better than humans do, I think they're good, right? And that's, but I think it'll be harder it's easy for me to think that way. But when an accident happens in front of Tesla, right, the news cycle just goes crazy, and they blame like these algorithms for making a mistake. But I think what gets ignored is, what is that accuracy, and is that accuracy better than human accuracy or not, right? Because there's no guarantee that if the humans are driving, there never will be an accident, right? So I look at it this way.
Awesome. Okay, so we have time for one last question, and that's going to be, what skills are needed for a computer vision engineer?
Yeah, I mean, if I have to say one particular thing, it's deep learning, right? You really need to know deep learning, the field of deep learning. At this moment, we don't even hire any bachelor's degree holders. The minimum degree that's required if you want to be an AI scientist in our company, is a master's degree. So really, you need to have a master's degree in computer science, or especially in AI field. Your graduation has to be in AI field and deep learning. And as long as you've done some sort of deep learning work in your theses and multiple courses in deep learning, I think that's when we can hire you as a computer vision engineer. Or if you take significant amount of deep learning courses on extension courses like these, right? If you already have a software background, and if you take these extension courses and there are deep learning courses or somewhere else, and you prove your deep learning sort of prowess to us, then that's a way to get in. Yeah, those are the skills that are required, really. And Python is another one, but deep learning is really the biggest one.
Awesome. Thank you so much for today. It's been an absolutely great session. I'm going to pass it back to Bruce for some closing remarks.
Oh, thanks, Crystal, and thanks, Vaibhav, for this wonderful, wonderful presentations and Q&A here, and we learned quite a bit. Now, for those of you that are interested in deep learning and computer vision, that here at Harvard Extension School, we do have the graduate certificate as well as the master degree in data science. In fact, we're actually going to have a computer vision course that at the graduate level that is offering in the next semester. So make sure that you look at the new catalog that comes out. But again, thank you very much. And thank you again for the presentations. And everyone, thanks for joining us. And the next session that we have coming up, which is the last session for the day, is at 3 p.m. That's when we're going to have Hossein Syed presenting the threat detection intelligence. And again, so Hossein is the Chief Information Security Officer for one of the largest healthcare system in the New Jersey area. So I will see you all at 3 p.m. Eastern time. Thank you very much.